Okay, hi everyone, should be connecting now, hopefully. Yeah, it's working. Yeah, there we go, now it's connecting. Okay, so we've got the June, well, it says May here, but I'll just go with June 2019 paper 1. The link for the paper is in the description. The link for the mark scheme is also in the description. I've also linked down below any of the topics from this paper that I've already done my own videos for. I've linked those as well if you want to go through anything else in more detail afterwards. But otherwise, let's just go through paper. Obviously, it's non-calculator because we're focusing on that for next week. Yeah, I might be able to have a look at your question at the end if you don't mind, Gina. Okay, so question 1, we've got probability. So there are only blue cubes, red cubes, and yellow cubes in a box. The table shows the probability of taking at random a blue cube from the box. The number of red cubes in the box is the same as the number of yellow cubes, hence complete the table. So if we've got the same number of yellow cubes and the same number of red cubes, and the probabilities are also the same, aren't they? So this is quite a nice one compared to the one we saw in the previous slide. This one's a little bit easier. So obviously all of these must add up to 1. So 1 minus the 0.2 to get rid of the blue is 0.8. And then obviously it's then shared equally, isn't it, in this case? This one's a little bit easier. You don't have to use x if you don't want to. 0.4. Because it is shared equally between them in this case. Okay. So part B, there are 12 blue cubes in the box. So again, it's a very similar question to the one we just saw, isn't it? So they've told us that there are 12 blue ones. We know the probability is 0.2. Work out the total number of cubes in the box. Exactly the same as I did in that previous question. If 12 actual cubes is basically the same as 20% of the box. Now, because this is non-calculator though, you can divide by 0.2 if you feel like you couldn't do that without a calculator, that's fine. I probably wouldn't want to do that. So what I would do in this case, because it's non-calculator, and you see how they've chosen 20% is much easier, is I'd go, well, I want to know 100% of the cubes. How do I go from 20 to 100? I would just times by 5. That's what I would do. I would just literally times by 5. Obviously, it depends on what percentage they've given you. That's why for 45%, we couldn't really do the same thing because it was kind of a random number, wasn't it? So times both sides by 5. 60 cubes is 100%, so you should get 60. Now, you can do 12. Oh, sorry about the noise. So you can do this if you want. That's what I would do if I had a calculator. You can also do this if you've not got a calculator, if you feel comfortable doing so. I probably would just stick to times by 5 because it's non-calculator. I think that's a bit easier. Okay, this is quite a nice one. It's just kind of, just general maths. It's normally always some kind of general arithmetic, what I'd call general arithmetic, when you're just dividing times and multiplying question in the non-calculator. So question 2, Dion needs 50 grams of sugar to make 15 biscuits. She also therefore needs 3 times as much flour as the sugar and 2 times as much butter as the sugar. So Dion is going to make 60 biscuits, work out the amount of flour she needs. So not only do we need to work out the flour in the recipe for 15 biscuits, we also then need to multiply it to make 60. So Sean, this is not a Q&A session. We're literally just going through the past paper. So if you've got questions about the questions we're looking at here, that's fine. If you have questions that are separate to this past paper, then we're not going to be answering them in this live. Okay, that's what the one before was for. So in this case, I'm going to work out how much flour she needs for 15 biscuits, which is 3 times, right? So obviously we're going to do 50 times 3 times, which is 150 grams. So that's for obviously 15 biscuits though. I actually need 60 biscuits. So you have to figure out, again, this is that whole thing about the 15 times tables. It's quite handy to know for a non-calculator. How many times does 15 go into 60? It goes in 4 times. So I would then need to take my flour and multiply it by 4. Which again is kind of the 15 times tables, isn't it? Because you've got 15 and then a 0. So you should get 600 grams for that one. Don't forget you need to multiply it twice to scale it up. Okay, part B, Dion has to buy all the butter she needs to make 60 biscuits. She buys the butter in packs of 250 grams. So we kind of need to do the same thing. The butter was 2 times as much as the sugar. So that would be 100 grams, but that's for 15 biscuits, isn't it? I also still want to know 60. So it would be 400 grams. But then you have to figure out, well, how many packs of butter can she buy? Because obviously I can't buy exactly 400 grams. I need to buy enough to get, in 250 grams packs. I can't just cut it to whatever I want. So you just figure out, well, how many times does 250 go into 400? Well, effectively, you'd need 2, wouldn't you? Because 1 wouldn't be enough. And if you double it, that would be 500 grams, wouldn't it? So you would need 2 packs. No, I didn't say I would answer in the next live. I said if it wasn't related to GCSE maths, and I wouldn't answer it, which I don't think that one is. As I said, if you want to look at SAT stuff, I would recommend looking at a live where the YouTuber is doing SAT stuff, because I have no idea about SAT stuff. Oh my goodness. Okay, you can see this one comes up all the time, specifically on non-calculator, isn't it? So highest common factor. Now there are 2 ways to do this. You can either do the product of prime factors and the Venn diagrams. That's the way I tend to do, just to be consistent. But these numbers aren't that big. So you could just list out the factors and then figure out the biggest one if you want. I prefer to do the Venn diagrams though, some people think it's longer, I think it's just easier. So I'm going to split it into the product of prime factors. So I normally start with 2 until it's no longer even, and then I would do 3 or 5. So 2 again. Now this one's already no longer even, so I'd probably do 5. Then you can just scribble some circles, doesn't have to be nice. Obviously see which overlaps. We've got a pair of 2s, haven't we, here? So that's in the middle. What else have we got in common? A 3 and a 3, haven't we? We've got 2 pairs of 3. So this pair here, and then this pair here. The rest, you don't really have to fill out the rest because that's for lowest common multiple, isn't it? But technically it would go like that, wouldn't it? So highest common factor is just the middle bit. So you just multiply those together. 2 times 3 times 3. Should get 18. If you listed out the factors and got 18 as well, that's also fine. Yeah, sorry about the noise, guys. They didn't tell me they were going to start bashing around today. They did it a few weeks ago and then stopped. So you could use the calculator, but the thing is this is a non-calculator exam, right? So you wouldn't have the calculator. So if this was on paper 2 or paper 3, then definitely. But this is not. This is paper 1, so you don't have a calculator with you. Yeah, so you'd have to work it out yourself. That's the only issue. Guys, if the noise gets too much, just let me know and we can kind of come back to this another day. Because I know it's quite loud. I don't know when they're going to stop. So the diagram shows the plan, front elevation and side elevation for a solid shape. Draw on a centimetre grid. So in the space below, sketch the shape. So the plan is like the bird's eye view, and then obviously the front side elevation is if you're stood in front of it, stood at the side of it, just looking at it. So this should be a cylinder, as you've said in the comments, cylinder. So you would just draw a cylinder, but you do have to put the dimension. So what I would probably do is either the radius or the diameter, which, because it's a centimetre grid, 1, 2, 3, 4, that's 4, isn't it? And then the height, that'd be enough for a cylinder. So that's 1, 2, 3, 4, 5. So that would be enough for that one. You have to have those two measurements though, those two, measurements, 2 marks. As long as they can recognise that it looks like a cylinder is fine. What do you mean it doesn't look normal? You don't know how to draw a cylinder. Just kind of like a squished circle, and then, I've not even drawn it with a ruler. I literally just kind of, I mean, yours might be longer, right? If you've drawn it like this, then I don't think they would care, as long as your, measurements are the correct ones. I just do like a circle, but I just kind of squish it, like that, literally, just like that. I don't think they would mind, if it doesn't look perfect. Like, this doesn't look perfect, does it? But as long as you've got that, they can recognise that it is a cylinder and not some other type of shape, and then that they've got the measurements. So a cube, I would probably draw the front face, and then I would do like the top, and then like that. Guys, obviously I'm not going to respond to any comments that aren't like questions about the exact paper, so that's why. Because that's not helpful to anyone else who's watching. Okay, so question 5. It's a bit small, but I just wanted you to be able to see the whole thing. Shape A can be transformed to shape B by reflection in the x-axis followed by translation CD. So I would probably draw the reflection first, like where it would go. So x-axis is there. Remember which one it is though. Sometimes you kind of think it's B to A. It's actually like that direction, isn't it? So don't obviously pick the wrong triangle. Reflection, so it's going to kind of go down, isn't it? Just count how many squares there is, the difference. And then it's 3 squares big, so down here. So that would be kind of the interim one, wouldn't it? Halfway. Then they've said it's translated. So I just need to figure out how to get from the one that I've drawn to B. Yeah, we're going to go through the whole paper, right? So we'll get to the last questions after we've done, obviously, these ones. So translation, C at the top is left and right, D is up and down. So I'm just going to count. 1, 2, 3, 4, 5, 6. Just choose, corners that match, right? That corner and that corner. So 6 to the left. Because it's left, it's negative, right? Be negative. And then it's also then down by 1, isn't it? So it'd be -1 for D. Yeah, exactly. -6, -1. Okay, so I would draw that interim one so you can visualize it, then count. So question 6, a shop sells packs of black pens, packs of red and packs of green pens. There are 2 pens in each pack of black pens, 5 in the red pens, and then 6 in the green pens. On Monday, the number of packs of black to red to green sold is 7, 3 to 4. Now this is in terms of packs, right? The ratio is in terms of packs of pens. They've then said in total 212 pens were sold. So see how that's in terms of pens? Work out the number of green pens sold. So we need to apply how many pens are actually in each pack to the ratio. So what I did was, they said black pens is 2 in each pack. Now I know 7 packs weren't exactly sold, it's some multiple of 7, but just imagine it was 7. Do you see how that would make 14 black pens? And then I do the same for each one. So red, 5 in each pack, so 5 times 3 is 15 pens, and then green, 6 times 4 is 24, so that's actually now in terms of pens, no longer in terms of packs, so you have to translate it. Okay. Yeah, that's fine. Come back for the last few questions, don't worry. They've probably been about, I guess, an hour. Okay, so now we want to share this out with the 212. So when you share out a ratio, you add them up. So if we add up 14 and 15, we should get 29. Add 20, 49. Add the 4, 53. However you want to add it up, that adds up to 53. Right? So then 212 divided by 53. This is question 6 and non-calculated, so it's probably going to be a nice number, right? If you divide that, it does actually give you 4. So what they're saying is there's 4 pens in each part of the ratio. They wanted green, so all I need to do is take the green and times it by 4. Or you can add it up if you want, double it again. So it should give you 96. Okay, 4 marks, 96 should be your answer. Next question, question 7. This is, I guess, you could use area with algebra in this case if you wanted to. So here are 2 rectangles. They've given us QR, which is 10, so I'll label that. They've said that BC is equal to PQ. That's how they relate to each other, that one and that one. So the perimeter of ABCD is 26, and then the area of PQRS is 45. So I'm obviously going to start with the area, right? Because I've got information about that one. Find the length of AB. So I need to start here and then go backwards. So if you want to, you can label this X. You can probably do it without doing that, but I'm just going to kind of show you exactly how I do it. Area is length times width, so that'd be 10x is equal to 20, not 26. 45, make sure you get the right one. Divide by 10 to get the other side length that we don't know, which is then 4.5. So, because that's the same as PQ and BC, that's also 4.5, isn't it? And then that one's also obviously 4.5 because it's a rectangle. Now, we're looking at perimeter. Perimeter is where we add all the sides together. So you could also call that y if you want. That's also technically y. We could create another equation if you wanted. Again, you could do it without the equations. So technically it's 4.5 plus 4.5 plus, I'm just going to put it straight as 2y, isn't it? Y plus y is 2y, 26. That gives you 9 plus 2y is 26. If I take away 9, we should get 17, and then half it, 8.5. That's the one we were looking for, wasn't it? AB. So you should get AB for that one. You don't have to do it with algebra. You can just do it, you know, you probably have to think it through in your head anyway, but just if you wanted to kind of structure it a little bit, then that's fine. Yeah, or you can leave it as 17 over 2. I think they would accept that, you know, because it's the equivalent, isn't it? They haven't said how to leave it. So if you didn't want to work it out, you could probably just put 17 over 2. Oh, where did I have my mark scheme? Check the mark scheme. I think they'd be alright with that, you know. They've said, oh no, they've said 8.5 or 8.5. No, okay, so they won't. Oh no, yeah, they've said accept 17 over 2. Yeah, they'll accept 17 over 2 if you don't want to half it. But effectively it's just halving it, right? So that's fine. And how many marks was this one? Hopefully they've quietened down now. 4 marks. That's quite nice for 4 marks, I feel like. But I feel like with non-calculus, there's always some kind of area with algebra type question, a bit like that. Okay, right, estimation's obviously going to be likely to be non-calculator if it comes up. So work out an estimate for the value of the square root of 63.5 times 101.7. Now, obviously, you're not going to actually work it out, right? That would be crazy. So we're going to estimate the numbers. We're going to round the numbers. Now, normally I would say with Edexcel, they normally want you to round to one significant figure. But the only exception is when there's some kind of square root or maybe a cube root. In this case, because the context is square root, I would round both of them to the nearest square numbers. So that might not be one significant figure. So as you guys have said, 64 and 100, exactly. So I would round it to, you can also, you know, in terms of Surds rules, you can split them. 64 and 100, so square root of that is 8, square root of that is 10. So 80, yeah. So round it to the nearest, if it's got a square root, round it to the nearest square number specifically, because they won't make you square root anything that is not a square number. Okay, they won't make you do that, so make it as easy as you can. Okay, I feel like this next question was probably the one that most people got stuck on. Part B. This one was quite hard. So they've told you that 2.3 to the power of 6 is 148, correct to 3 significant figures, obviously. They've said, using that information, find the value of 0.23 to the power of 6. Again, correct to 3 significant figures. So obviously it's going to be a version of 148. We just need to figure out where the decimal place goes. So some people use, I would probably suggest it's similar to, like it's a little bit like standard form, isn't it? A little bit. So I would probably use that. That's my logic. So what you can do is say that 0.23 to the power of 6 is the equivalent in standard form of writing this 2.3 to the power of times 10 to the power of minus 1. That's the equivalent, isn't it? And then obviously that would be to the power of 6. So then, if we actually apply index laws, the only thing is 60 times 100, I don't know how you would square root that. Like, how would you know what the square root of 60 is? Because 60 is not a square number. That's the only thing I'd say about that. I wouldn't round it to one significant figure in that case, because I don't know what the square root of 60 is. And they won't make you square root. Yeah, they won't make you square root something that's not a square number. So that's the only reason why I made it into square numbers. So that's the same thing. If I were to apply this index law, this is index law number 3, isn't it? You know when you have the brackets and you multiply the powers? So do you see how that would be the same? Because technically that's to the power of 1, isn't it? So that would be the same as 2.3 to the power of 6 times 10 to the power of minus 6. Now this is where this relates. We know what 2.3 to the power of 6 is. It's 148. So do you see how I can sub that in? And now this is just standard form. And then standard form, because you have to, it needs to be a square number because you have to square root it. Otherwise, how would you square root it? Now it's just moving the decimal place, isn't it? So you're basically taking, if I write it over here, 148, decimal place here, I'm moving it to the left 6 times. So 1, 2, 3, and then another 3, 1, 2, 3 there. So it would be, that would be your answer. Now, that's the way I would do it. I'm pretty sure there's loads of other ways to do it. As long as you get this answer, then it's fine. Yeah, you could do a different... Because the reason why it wouldn't be 0.148 is because you're multiplying 0.23 by itself. And so if you're multiplying numbers that are less than 1, like as in 0 point something, every time you multiply them, it's going to get smaller and smaller and smaller and smaller. So 0.148 wouldn't be small enough, if that makes sense. It wouldn't be small enough. Effectively, you're taking 23%, if you think about it like a multiplier. Every time you're figuring out 23% of the previous answer, so every time it's going to get smaller. I don't know how it's 1 mark, honestly. Like, I would at least expect 2. But this might be a 1 marker that you're like, you know what, I'm just going to gain the mark somewhere else. We're not going to worry. Hang on. Can I make it a fraction? That's just how I did it. There might be different ways to do it. It depends what you're doing with the fraction. I mean, if you've got the same answer as me, then yeah, you can do the method that you were suggesting. 2.3 divided by 10. Yeah, actually, yeah, I guess that would make sense. You can also do that. If that makes more sense to you than the standard form, yeah, that's probably a good way to do it. Part B again, yeah, that's fine. I'm not an exam marker, no. I'm just a GCSE maths tutor, but obviously my speciality is A, GCSEs particularly, and B, Edexcel mostly. I'm kind of aware a little bit of AQA, but I haven't really done much AQA. So that's why I'm quite kind of niche focused on this. Yeah, I don't know how that's 1 mark. Yeah, the part C is fine. Let me go through part B again for you. So this is one way to do it. If you read Akram's message, he's done it a different way, which also, that might make more sense to you. So have a read of his comments as well, because I think he's done it in quite a good way. This is just, because I was looking at it and I felt like it seemed a bit like standard form. That's why I translated it into standard form, just because that made sense to me, but you might prefer Akram's method, which is also fine. So I basically said 0.23 is basically this bit here. Does this bit make sense? Like why that and that is the same? 0.23 is the same as 2.3 times 10 to the minus 1, because that's just putting it into standard form. All I've done there is put it into standard form. Obviously the 6 as a power is still there. That bit there is just standard form, right? So you know a standard form, it has to be, like this number here has to be between 1 and, I say 10, but technically 9.999. It has to be 1 digit in front of the decimal place. So 0.23 is not in the format, is it? So you have to... Why is the power of 1? Oh, yeah, so the only reason I've written that is because, well, technically any number has a power of 1. Like that's the power of 1, that's the power of 1. Obviously, we just don't write that, do we? Because it makes no difference. The reason why I wrote it here was just to show you this step. That when I apply the power of 6, I'm multiplying power of 1 by 6, which makes 6. Because some people think with this index law, they think they need to multiply the 2.3 by 6, but it's not, is it? It's the power. And if it's just 2.3, then it's just 2.3 to the power of 1. Any number that's just sat there on its own has a power of 1. 2.3 times 10 to the power of 5 because 6 minus... No, so that's if you add them, right? When you have the brackets, you know when you see brackets, that's the what's it called, index law, where you multiply. So you see how I've multiplied minus 1 by 6. It would be minus, I'll show you the example just here. If it was like this, do you see, oh, hang on. Do you see where it's written twice? The base number 10 is written twice. Then yeah, you would add, that's when you add them. Do you see here how there's not 2 base numbers? It's just 10 to the minus 1 and then to the power again of 6. So that's the index law where you multiply the powers. So it's just being clear of the difference between when you multiply the powers and when you add the powers. We don't add the power in this particular case. So that's why I got both of them were then to the power of 6. Well, the other one was to the minus 6, I guess, wasn't it? And then if I highlight, and then the reason why that was helpful to me is because they told me what 2.3 to the power of 6 was. So I could, you see how I just substituted that in? Yeah, do you see how I just from the information they gave me, I just replaced it because they told me that 2.3 to the power of 6 was 148. So I just replaced it. Yeah, if Sean, if you keep spamming, I'm going to have to, like, kick you out, to be honest, because it's not helpful for everyone else. We're either discussing the paper or you don't have to, like, no one's forcing you to be here. So, but does that make sense? That I just replaced the 2.36 with, the 2.3 to the power of 6 with 148 because they told me that, not because I knew that off the top of my head. Obviously, I wouldn't know that naturally. And then I just did that because I was like, oh, well, that's just standard form, so I'm just moving it 6 times. But I don't know if you saw Akram's message, because his also makes sense as well, if you prefer his method. That also makes sense. Okay, yeah, it's a random question. I don't think they asked that one repetitively, so I wouldn't necessarily worry too much about that one. Again, 1 mark, we can afford to lose a mark. So part C, find the value of 5 to the power of -2. He put it as a fraction, like he divided it by 10, if that makes sense, but you can obviously tell you again. We just have to memorize how negative powers work here. The negative means reciprocal, so the reciprocal of 5 is 1/5, right? Just if it's a whole number, put a 1 at the top. And then obviously the 2 does apply as a normal power, so you would have to square the 1, which is obviously still 1, square the 5, 25. There should be no negatives in your answer because the negative only makes it a reciprocal. It doesn't, like, add a negative or anything. I'm going to try and see. Where did he put it? He said when you can't... he just put it like 2.3 divided by 10 to the power of 6, which is then 148. Yeah. It's just, his comment is just above where you said if we can go through part B again, it's just above that. Oh, perfect, thanks. I can have a look at that email later on. Oh, well, you can, whichever one of those might make more sense. It is only 1 mark, and I don't think they repeat that question. I've only seen one of that question before. So I can write out his method if you want. It might be easier if not on text. So he was saying, we're trying, do you see how because they told us what 2.3 was, we have to kind of compare, therefore, how that's different to 0.23? 0.23 is the same thing as doing 2.3 divided by 10, isn't it? That's the same thing. That's just maths, right? So then he was saying that it's to the power of 6 is this also to the power of 6, which is then 148 over 10 to the power of 6, which then means just divide it by, like, move the decimal place 6 times. That's what he was saying. Because, again, we're using that logic. They told us what 2.3 to the power of 6 was. But yeah, I haven't seen that question repeated, so I wouldn't really worry. I'd more worry about the negative powers and all that. That comes up all the time. Okay, as I said in the previous live, when you were asking what comes up in non-calculators all the time is some kind of fractions operation, so multiplying, but mostly we've got improper fractions, mixed numbers. That's kind of the format that it comes up in. So when you're multiplying or dividing, you have to make them into improper fractions. So 3, the whole number times the denominator. 3 times 2 is 6 plus the numerator is 7 out of 2. 1 times 5 plus 3 is 8 out of 5. Now we're just multiplying, so I can multiply straight across. 56 over 10. Now they have said 2 things. 1, give your answer as a mixed number. 2, as its simplest form. You can do it in whichever order you like. I tend to simplify it first. Well, actually, I don't know. It depends. You could simplify it second. It's up to you. I think in this, well, yeah, this one might be easier to just convert it back. So obviously, how many times does 10 go into 50? 6, 5. There's a remainder of 6. But then I would simplify that fraction. So that would be 5 and then 3/5. Yeah, you'd have to simplify it as well because they've asked for the simplest form. Yeah, so Sean, you can't do that because you see how you get, if we did that, let's say you get 3 times 1, which is 3, And then if you multiplied the fractions, you'd get 3 over, so you'd get like 3 and then 3/10 if you did that. Do you see how that's not the same? So you can do it when you're adding and subtracting. You can add the two whole numbers separately or subtract them separately, add and subtract the fractions separately if you want. But in terms of multiplying and dividing, you have to make them mixed numbers. Well, you have to make the mixed numbers into improper fractions. So yeah, you can't just multiply them separately, because you see how that's not equivalent at all, is it? So no, you'd have to convert them. And then if they've asked you to convert them back, then convert them back. Okay, another one that I mentioned in the other live that would come up, some kind of simultaneous equations question. Why? Just because that's how it works, I don't know. That's just, you can see why not, because it didn't work, did it? We didn't get the same answer. So some kind of simultaneous equations question is likely to come up. Obviously it could come up in any of the papers, but I do see it come up quite a lot in non-calculator. This one's obviously graphically. So they've drawn the graphs with equations. I mean, in this case, you need to read the equations because they've drawn it for you. They're basically two straight lines that they've drawn. Using the graphs, find estimates of the solutions of the simultaneous equations. All that is just seeing where it crosses. Because they're both straight lines, they're both linear, we're obviously going to have one x and one y. Yeah, the point where they intersect, exactly. So you're just going to read it off as best you can. And see how the question says an estimate, so don't worry if it's not. I would do it to like 1 decimal place. It doesn't have to be that specific. There and there. They do give a very, very small range of answers, because obviously you might read it off slightly differently. So here I would probably go with, what's that? Be careful of the scale as well. It's kind of in between 2.2 and 2.3, so you could put 2.35, but normally, yeah, I think they would accept 2.25. Even just 2.2. Normally to 1 decimal place is fine. And then this one, what's that, minus 1.3? That's what I would go with. Now I'll give you the range of answers that they've given. They will accept for x anything between 2.2 and 2.3. So if you've got 2.25, that's fine. If you've got 2.2, that's fine. 2.5 is fine. 2.25, sorry, is fine. 2.3, any of that's fine. And then y, obviously it's negative. They've said anything between minus 1.3, which is what I got, to minus 1.4. So anything between those for y. Okay, so anything between that range is fine, but all you do is literally just look at where it intersects. So that's a really nice 2 marks. Okay, question 11. So a bus company recorded the ages in years of the people on coach A and the people on coach B. Here are the ages of the 23 people on coach A, just listed in order. Complete the table to show the information about the ages of the people on coach A. So we need the median, the lower quartile, upper quartile. So the median is obviously the middle one. Yeah, because it's odd, I think they've done that deliberately. I would add 1, half it, so then that's the 12th person. Now, some people do go through and cross them off, but I wouldn't do that. A, because there's quite a lot of numbers, and you could get mixed up. And B, because you're going to want to read the numbers afterwards. Now, it's kind of obvious this one. It's like the one that's sticking out in the middle, isn't it? So the 12th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that should be 59. And then it's kind of similar for the lower quartile and upper quartile. You just have to remember that the lower quartile is 1/4 or 25%. The upper quartile is 3/4 or 75%. So in the same way, I would probably add 1 to make it even. And then for 1/4, I'd obviously just divide by 4, right? So that would be 6. So 1, 2, 3, 4, 5, 6 for the lower quartile. Now for the upper quartile, you can count 6 back from the end. Yeah, exactly. You can count backwards. Yeah, you can do it backwards. Or if you want to know 3/4, obviously just times that by 3, which is number 18. So I'd probably just count back 1, 2, 3, 4, 5, 6, 66. So that's it for part A, 2 marks. And then they've said, here is some information about the ages of the people on coach B. So that first one was coach A. Now this is coach B. They've given us the same table. Richard says that the people on coach A are younger than the people on coach B. Is Richard correct? So 1 mark, obviously you say yes or no, but the mark is for your reasoning, right? I would look at, when they're saying, he's kind of saying on average, because obviously we don't know the actual numbers for the ages of Coach B, right? We don't know that. So I would say that on average, are they younger? When you're looking at on average, it's normally the median. So I'd look at both medians. He's saying Coach A is younger. Well, 59 and 70. I'd say, yeah. Yes. And I would say, because the median, I think you have to make a comparison. Because median ages, I think you have to relate it to the context if you can as well, of Coach A, which is 59, is lower, is less, is smaller, whatever you want to call it, than median ages of Coach B is what I would write, which is 70. So it's comparing the median. Normally when you've got worded questions to do with, it could be laid out like this, it could be box plots, could be cumulative frequency, whatever, in the case that you can work out medians, upper and lower quartiles. Normally it's something to do with the median, that's obviously a key point. And then there's actually a part C, the other thing they normally want you to mention relates to this one. So Richard says that the people on Coach A vary more in age than Coach B, so like the spread or the range. So normally you mention something about a median, which was the first question, and then something about some kind of range. You can either do the interquartile range or the total range, the greatest and the smallest. So is he correct that the people vary more, the ages vary more in Coach A than B? Let's have a look. So A and B. I normally go with interquartile range, but I think they will accept either because they have given you the least age and the greatest age. You could look at that as well. But the interquartile range of this one, obviously you subtract them, right? So 66 minus 53 should give you 13. And then the interquartile range of Coach B, 73 minus 54, I'm pretty sure gives you 19. So, hang on, which one did he say? He said that A is more varied, that A has a bigger spread, has a bigger range. Well, is that true? No. So that's what I would say. I would say, is he correct? In this case, no, he's not. Because the interquartile range of ages of Coach A, which is 13, isn't it, is actually less than, and you say the same for Coach B, right? Interquartile ranges. Interquartile range of, why have I said years? Of ages. Coach, doesn't have to even be a full sentence really, as long as they can understand what you're saying, which was 19. That's what I would say. So a lot of the time you're focusing on median and some kind of range, interquartile range or the total range, depending on what information they've given you. In this case, it was split into two questions. Sometimes it's in the same question. Okay, question 12. So here are three spheres. The volume of sphere Q is 50% more than the volume of sphere P, and then R is again another 50% more than Q. Find the volume of the sphere P as a fraction of the volume of sphere R. Now we don't have numbers, so you can either use multipliers or numbers. You said in the comments you've made P 100%. That's exactly what I would do. When you're not given numbers and they've got fractions or percentages, I tend to use 100 as my base number. So I say, like, let's say that P is 100, or as you said, 100%. If that's 100, we are adding 50%, aren't we? So you see how Q would be 150 times in by 1.5, because that's adding 50%, isn't it? That's a multiplier. And then R, again, we're timesing that answer, so the 150 by 1.5, or you're just adding 50%, add half of it, however you want to work it out. You should get 225. Not 200 though, just double check that. Yeah, not 200. Yeah, just double check the R1, because it's another 50%. So 50% of Q is 75, isn't it? We're adding 50% of Q, not 50% of P. Yeah, because you added 50% of the 100. We're adding, do you see how it says R is 50% more than the volume of Q, not of the volume of P originally? So yeah, exactly, 50% of 150, which is 75. So 150 plus 75 is 225. So then they want it as a fraction, so you just put it in the order that they've said. So P is the numerator, R is the denominator. Now you can simplify it if you want, you don't have to, they haven't said that. So they will accept 100 over 225. If you did simplify it, the most simplified is 4 over 9, but you don't have to do that. Yeah, just be careful of the wording because it says 50% more of Q, not 50% more of the original. So just be really careful with that. But yeah, you can put numbers to it, and when it's percentages, I tend to just choose 100 as my starting value because that's quite easy, isn't it? That's 3 marks. So either, or some equivalent fraction of this. Just remember it has to be P at the top and then R at the bottom though as well. You're saying 50% more than 150. 50% of 150 is 75, not 50. Because it was 50% of 100 is 50, isn't it? So you add that and you get 150, that's fine. But now our new starting value is now 150, and you're adding 50% over 150. So we would add 75, which is half of 150. That's what I'd put in the calculator. I guess, you could work it out without. Oh, if you're adding 50%, it's times by 1.5 because the 1 is 100% because you're including your original plus another 50. So 1.5 would be your multiplier. You don't have to write it out like this as such, as long as you get, these values. But so in this case, you're kind of adding 50 because that is 50% of 100, isn't it? But then in this case, you're adding 75 because 75 is 50% of the 150. So as long as you get some equivalent of this fraction, then that's fine. Okay, algebraic proof, again, another one of those ones that I mentioned might come up. Might make this a little bit bigger, actually, if it's going to let me. Yeah. Make this a bit bigger for now. This one was kind of an odd one, actually. I found this one a little bit harder than normal. So, given that n can be any integer such that n is bigger than 1, prove that n squared minus n is never an odd number. Normally, algebraic proof is a lot of expanding brackets and then factorizing at the end. In this case, there's nothing to expand. So yeah, exactly. I would factorize that obviously into one bracket, right? You'd get this. Now you have to kind of know what this means. What is this telling you? So they've said that it's never an odd number. Here, we're multiplying two numbers together. Now with algebraic proof, you're never going to substitute numbers in, right? So don't, yeah, you could factorize it like that if you wanted to. That just seems more complicated to me but you can if you want. Well, actually, yeah, you can if you want, but I don't know why. That seems harder to factorize it that way. I would just factorize it like this. So, do you see how, if you've got n, so let's pretend in your head n is a number. N minus 1 is the number before it, isn't it? It's the number before, isn't it? If you think about a number line, if you've got a number, if you then take away 1, it's the number before. Now think about that. Think about consecutive numbers. In a number line, consecutive numbers, 1 is always odd, 1 is even. It doesn't matter which order they come in, because what I did is I said, right, so this is the product means, you could say multiply if you want, product means multiply, of consecutive, so numbers that come after each other, consecutive numbers, well, integers, let's say more specifically, because they've said that n is an integer, isn't it? N is a whole number. Integers, which is another word for whole numbers. That's the product of consecutive integers. So then the way that I demonstrated it was I said, well, even times odd, that will always give you an even answer, won't it? And then let's say swap them around. Let's say n was odd, the n minus 1 would have to be even. Also, even, isn't it? So that's like, therefore, never odd. I don't know, it's kind of hard to kind of... Yeah, don't substitute... Yeah, no, don't substitute, because it says prove... Well, actually, it doesn't say here, to be fair. Normally it says prove algebraically. This is algebraic proof. They want you to prove that it's never an odd number. Imagine how many values of n you'd have to test out. You'd have to test from 2 to infinity. You obviously can't do that to get 2 marks. So normally algebraic proof is not substituting numbers in. Normally you're kind of using the algebra. I do have a video on it, which I think you might find helpful. I've linked it in the description anyway. Have a look at that video at some other point, because it's just by figuring out what these numbers mean. N could be anything, but then n minus 1 is 1 before that. So that's consecutive. What does that mean? It means one's odd, one is even. You know, like you're kind of piecing these things together. This one I think was harder than normal though. The ones I put in my video I think are easier than this. Or a little bit, you know, once you know the method. This one was kind of a little bit harder to figure out. But normally it's some kind of, not exactly like this. It's obviously got a variety of the other types of questions I've seen in Edexcel though. So normally it's something like, show that the square of 2 consecutive odd numbers is always a multiple of 8 or something. That's normally what it is, isn't it? So there's loads of those ones. Normally what you would do is you would expand things. In this case I couldn't expand anything, could I? There was nothing to expand. But normally you would expand brackets, and then at the end you'd factorize to do your proof. But yeah, watch that video because that will help. But how is it never odd? Because, does it make sense that this is like, if you've got n, imagine, you can always in your head imagine that n is an actual number. Let's say if n was 5, just for, I wouldn't write this in my working, but just for example, if n is 5, do you see how n minus 1 would have to be 4? Now, they're consecutive numbers, aren't they? As in, they come one after each other in the number line. Whatever I substitute in for n minus 1 is always the number before that, which is consecutive. Now think about number line. 1, 2, 3. Consecutive numbers, you see how this one's odd, this one's even, this one's odd. It always goes like that, doesn't it? Odd, even, odd, even, odd, even. So if n, I just kind of gave like an example. If, let's say n was even, do you see how I'd then be multiplying it by an odd number? Now think about it, when you multiply any odd number by an even number, you always get an even answer, don't you? That's just maths, you just always do. Then I did the opposite, I just said, well, what if n was actually odd? Then the second number would have to be even, wouldn't it? Again, think about the number line. And that still gives you an even answer. So either way, like either possibility, it would be even, which therefore is never odd. You see how I've proved that for every possible value of n? I've not just proved it for like 1 to 10, for example. I proved it for every possible value. Yeah. So that's why we don't want to substitute numbers in. Because if you substitute numbers in, you're only proving it for those numbers. I know it's kind of, it's hard to know how to do it and if you haven't seen it explained before. Once you've seen it explained, I feel like you can kind of put the dots together, like you can put 2 and 2 together and be like, yeah, that makes sense now. So yeah, have a look at that video definitely after this or another day. I think that will explain a fair amount of them, of the different possible ones. Okay, this one, obviously with non-calculator, you're supposed to know the values. So, I don't know, well, it's next week, isn't it? So, you're either going to know them now or you're going to memorize it the night before, I don't know. Either way, find the exact value of tan 30 times sine 60. So, tan 30 we should know is root 3 over 3, and then obviously multiply it by sine 60, which is root 3 over 2. At this point, it's just surds, really, isn't it? Yeah, well, however you want to memorize it is fine. If you memorize the table, there's loads of different ways to memorize it, I'm pretty sure. However you want to memorize it, as long as you've got those values, that's great. So when we multiply it, you can either write it as root 9 if you want, but technically that just cancels out, doesn't it? Becomes 3 over 6. They want it in its simplest form, which is a half, 2 marks. That's really easy if you've got, you know, if you memorize it. I don't memorize it because I don't have to do the exam, is what I would say. Because I don't have the exam, so I don't memorize it. I'm trying to remember. I think the way I did it, which is probably not the most efficient way. Yeah, I did the table. So I think I just memorized sine, and then cosine or cos is the opposite direction. Right? So if you've memorized sine, you can do cosine because you just do the opposite direction. And then tan, I don't know if you know this. This is actually an A-level thing. Tan is actually the same as sin over cos. So if you know sine, you can figure out cosine by doing it opposite direction. And if you know both of those, then you can divide them to find tan. That's what I did. I mean, I don't think that's very efficient, to be honest. It's probably not very efficient. I know some people do something with their hands. I don't remember what it is. You could probably look it up on YouTube as well. There's like a method to use your hands to figure out what they are. I don't know. There's loads of different ways to memorize it. That's, I think, what I did. But again, not exactly. The table was in, well, how would I lay it out? I mean, you might lay out in differently, but you obviously need to know 0, 30, 45, 60, and 90. So there's like 15 values you need to know. 0 and 90 are quite easy because they're on the graphs anyway, aren't they? Sin, cos. Maybe he's talking about this, or you might have it the other way around. So I know that sin of 0 is 0 because I just know the graph. I know that that one's 1. Cos is the opposite, so that's 0, that's 1. The others I actually don't know. But obviously I would have memorized it if I had the exam. What was it? Sine 30 is a half. So if sine 30 is a half, then that means cos 60 is a half. I think the 45's root 2 over 2, and then cos 45 is exactly the same. And then, well, we just said sine 60 was root 3 over 2. So then cos 30 is root. Do you see what I mean? They're the opposite. They're just in the opposite order. Oh yeah, Akram's got quite a good one. And then in this case, I just divided it. So 0 divided by 1 is 0. 1 divided by 0 is NA, because you can't ever divide by... Oh, what is going on there? You can't ever divide by 0. And then that's not the most efficient way to do it. I think Akram's probably got a better way than I have. But yeah, you can technically figure out that way if you want. But yeah, just figure out a method that works for you for memorizing it is what I'd recommend. Different methods work for different people. And then you just divide those to fill them in. Obviously that divided by that is 1, isn't it, anyway, so that's fine. That one becomes root 3 over 3. And that one's just root 3. I don't know. Yeah, I guess it goes in order 1, 2, 3. 0, 1, 2, 3. 0, 1, 2, 3. Yeah. Yeah, you might have a different method. Yeah, there's so many different ways. I'm not saying that mine's the best. Yeah, so 1 over root 3 is the same thing as root 3 over 3. It's just that the version that I wrote down was rationalized versus non-rationalized. It's the exact same thing. You might have memorized the non-rationalized version, which is also fine. So some people have it in the format that I've drawn it. Some people have it in a different format where it's not rationalized, which is also fine. They're still the exact same values. So you might have memorized this table. You might have memorized the non-rationalized version, which is also fine. As long as you've got, as long as you memorized it, then it doesn't really matter. So yeah, whatever method you want to use to memorize it, that's kind of more of a personal thing to you, whatever works for you really, isn't it? Okay, let's have a look. Question 15. Again, cones, spheres, hemispheres seem to come up quite a lot on non-calculator for some reason, but obviously you won't be working out the value of pi. So we've got the diagram shows a solid shape. The shape is a cone on top of a hemisphere. So again, just be really careful. With Edexcel particularly, they always give you the formula for the sphere. In this case, we have a hemisphere, so you're going to have to remember at some point to half that. So just be really careful of that. The height of the cone is 10. The base of the cone has a diameter of 6. Again, they pretty much always give you the diameter. Obviously, all of the formulas are in terms of the radius. So don't forget to also consider that. Sometimes I draw it on just to remind myself. Like sometimes I'll just kind of draw here and go 3. Just to remind myself to not use 6. The hemisphere obviously also has a diameter of 6. The total volume of the shape is k pi centimeters cubed, where k is an integer, a whole number, so work out k. That basically is just saying work out the volume and obviously tell them what coefficient you got. So we can do the volume separately. It's compound shape. So volume, let's do the cone first. So a third pi, again, remember it's the radius, not the 6. The 6 is the diameter squared times the height. So the way I work this out is 3 squared is 9, times 10 is 90, and then a third of that. So divide by 3, it's 30 pi. I literally just did that. Okay, and obviously leave it in terms of pi. And then the volume of the hemisphere, now don't forget though that we want to half the formula. So 4/3 pi radius, so 3 cubed, but then that is over 2. So don't forget to divide it by 2. There's just kind of a lot of things to remember here. So then I did 3 cubed, which you know is 27. If you divide it by 3, so divide by the denominator times by the numerator, divide by 3 is obviously then 9, times by 4 is 36. So you get like 36 pi at the top over 2, which is obviously then 18 pi. And then the total, we obviously add them. This one was quite a nice question, I think. Oh, that's the answer. Would give you 48 pi. Now they've obviously asked for k, so the actual answer that I'm going to put in the answer kind of line is the 48, because obviously the pi is not really relevant there. So yeah, it's really easy because you just have to use the formulas, but just be careful of what you might need to half. Radius and diameters, they tend to give you the wrong one. Sphere, hemisphere, they tend to give you the wrong one, so just be careful of that. But yeah, that's a nice 4 marks. Just have to be also really happy with fractions as well. Okay, this topic is called product rule for counting. That's the actual name of it if you're wondering what it was called. So there are 3 dials on a combination lock. Each dial can be set to one of the numbers 1, 2, 3, 4, or 5. So there's 5 options, right? 5 possibilities. The 3-digit number 553 is one way that the dials can be set, obviously as shown here. Work out the number of different 3-digit numbers that can be set for the combination lock. So product rule for counting, when I say product rule, product means multiply, doesn't it? So what you do is you just take, for each I call it a category. In this case, it's each like lock dial, isn't it? There's 3 dials. How many options do I have for dial number 1? Well, I have 5 options. How many options for dial number 2? Another 5. How many options do I have for dial number 3? Another 5. So yeah, as Akram has said, we're just going to literally, they're giving you loads of space to make you feel like you need to test out combinations. We're not going to test out different combinations because you would literally be there all day. You're literally just going to times it, which is 5 cubed, which is 125. So that's part A. However, part B is kind of helpful just to see then what would happen if we can't repeat digits. So they've said here, how many of the possible 3-digit numbers have 3 different digits? So you see how the previous, like the example they gave, had 2 5s in it, it repeated numbers. In this case, we can't repeat numbers. So what you've got to imagine, just going to draw it really badly, is, okay, if my 3 categories, how many options do I have? So dial number 1, I haven't chosen anything yet, so technically I've got 5 options, haven't I? However, when I get to dial number 2, then I've only got, because I've already picked one of the numbers for dial number 1, I've only got 4 options left. And then for dial number 3, I've already picked 2 options, haven't I? So there's only 3 left. So I would times those to not repeat. So that'd be 20 times 3, which is 60. Hang on, let me just come back. Why is it 5 times 5 times 5? Well, first of all, it's multiply just because that's just how it is. The multiply bit is just, because it's called product rule, you just have to multiply, you just have to know that. Whenever there's a combination question, you just multiply the number of options you have. Now, it's 5, the number 5, because you see how they said there was options of number 1, number 2, number 3, number 4, number 5. That's 5 options, isn't it? So you see how for dial number 1, I could pick any of the 5 options. So that's 5. For dial number 2, I could pick any of the 5 options. That's another 5. And for dial number 3, same thing, right? I could pick any of the 5 numbers, the 5 options. So then I just do 5 times 5 times 5. You just see how many options you have in each category. In this case, the categories are the dials, right? Obviously, each time you get this question, it's normally a different context, which is why I'm trying to give you kind of like a vague explanation so you can apply it to different contexts. I do also have a video on this one as well that you can look at with different types of questions so you can see how it applies. Because I feel like this one is quite handy when you've seen multiple questions, you can start to see the pattern. So that was 5 times 5 times 5 because every time there was 5 options, they didn't mind if we repeated numbers. Part B, though, is fewer options because they don't want us to repeat numbers. So the first dial, I still had all 5 options because I hadn't chosen a number yet. But then when I then pick a number for dial number 2, I've already chosen a number for dial number 1. So in terms of not repeating, I've only got 4 other numbers that I could choose from. And then the same with dial number 3, I've already picked 2 numbers for the other 2 dials. So there's only 3 other numbers left that aren't repeated, if that makes sense. So in that case, it's 5 times 4 times 3, which is 60. So that's the difference between the two. The first one, you can repeat the digits in each dial. The second one, you can't. Okay, I don't know if that answers your question. I have linked this one, a video of this in my description as well. Okay, so if you wanted to have a look at kind of more, sometimes it's like, you know, when it says they have 3 different options for starters, 5 different options for main courses, and 2 options for dessert. How many possible combinations? That's the exact same question. You just do those numbers multiplied. Or this person can, okay, Sean, if you're going to keep spamming, I'm going to have to like kick you out because you know, it's not really a relevant question, is it? Okay, so yeah, it could be they have 5 different tops, they have 3 pairs of jeans, they have 2 pairs of shoes, like, you know, how many possible combinations of outfits? That's the same one, isn't it? That's the same topic. It just applies to different contexts. Okay, so question 17. Given that x squared to 3x plus 5 is the same thing as the ratio 1 to 2, find the possible values of x. Whenever it says find x, we need to find an equation. We need to create an equation. So there's a way to link 2 ratios into an equation. You just have to memorize how it works. So I normally write it below. The way that I do it is that it's opposite, like I multiply them across. So for example, I could write 2x squared, so you have done 2 times x squared, is equal to 1, draw the arrows, 1 times the 3x plus 5, which is obviously still 3x plus 5. I just multiply it. Some people put it as a fraction. You can also, that's one way you could translate it into an equation. Some people put it as, for example, x squared over 3x would be the same, and then you just copy it. In that case, you would copy it straight across, so the 1 would relate to the x squared, and the 2 would relate to the 3x plus 5. Either of those, that's the same equation, isn't it? Hi, Gina. Yeah, I can look at your question at the end of this paper. Once we've done this paper, we can have a look, okay? So whichever way that you memorize how to convert 2 ratios into an equation, that's up to you, one of these 2. Obviously, at this point, I can now just solve it. I can forget about the ratio, can't I? So it is a quadratic, which means that I want to have all of my terms on one side of the equation, and I want it to equal 0 on the other. And I always choose the side of the equation, like which side to move the terms to, wherever the x squared remains positive. So I would probably move the 3x and the 5. So minus 3x, minus 5. And then it says find the possible values of x. I would assume that we could factorize this, given that it's non-calculator, given that they haven't said to round it to anything. So I'm going to factorize it. So 2x and x equals 0. I obviously need to put a plus and a minus, and then it's multiplying to make 5. So I think it was 5 and 1. So 2x, yeah, minus 2x, no wait, other way around. Minus 5 plus 2x. There. Again, I've got videos on factorizing, which is linked in the description, so I'm not really going into detail for that. So then I can solve it. X is 5 over 2, positive or minus 1. Find the possible values of x. Those are your possible values. So really, you just need to know how to set up that equation initially. Once you know how to do that, it's just a quadratic. So I think that was a nice 4 marks if you know how to make that equation initially. Question 18, we've now got surds. So express root 3 plus root 12 in the form a root 3. They've given you a bit of a clue, basically, by telling you what the surd is left. But when you add or subtract surds, you can only add or subtract them if they are the same surd. Currently, this is a 3 and this is a 12. It's not the same. So what I would have to do is I would have to simplify, in this case, just the 12, because the 3 doesn't simplify. But if you had multiple, you could simplify both. Simplifying surds, you split them into 2 factors, but one of the factors has to be a square number, which is why I chose 4 and 3 and not 6 and 2, for example. 4 is obviously a square number, so then do you see how I can square root that to become 2 root 3? Now, this is technically 1 root 3 here, so if I add them, do you see how that's 3 root 3? So that would be that, 3 root 3. They do give you a clue as to the fact that there's a root 3 left, so you know you should split the 12 into something root 3. Now, part B, I think, is the harder one. So, express 1 over root 3 to the power of 7 in this format. Obviously, we don't have a calculator, so I think there's different ways to do this. The way that I looked at it was converting, you know how a square root, you can convert it into a power? so I could convert it into a fractional power. That's what I did. I feel like you could probably do it a different way though. So I rewrote the 3 as 3 to the power of a half, because that's the same as the square root of 3, isn't it? Then I used index laws, so I applied the power of 7. Obviously 1 to the power of 7 is still 1, so that makes no difference. But we're multiplying the powers again. Remember, when you've got the brackets, you multiply the powers. So that would be like 3.5 or 7 over 2 if you want to write it like that. Now, obviously, the thing is they do want it as a surd, don't they? So what I saw with this is it's kind of the same. I'm going to write it over here. 3 to the power of 3.5 is the same thing as writing 3 to the power of 3 times 3 to the power of a half. That's also index laws, isn't it? You can kind of split it back up. 3 cubed is obviously 27, and then 3 to the power of a half, obviously I don't know what that is, but they want it as a surd. So do you see how I could write that as 1 over 27 root 3? So I've applied the power of 7. The last thing that I then need to do is obviously, do you see how their answer is rationalized? They don't have a surd in the denominator. They have rationalized it. So because it's just a single surd, I'm going to multiply both sides, or both, numerator denominator by the surd itself, which gives me root 3 at the top, over 27 multiplied by, technically root 9, but again, that would square root to become 3. So do you see how I get root 3 over 81? I think 3 to the power of 4, or 27 times 3, is quite a handy one to memorize as well. So you don't have to work it out. So you should get root 3 over 81. That should be your answer. They have said an equivalent fraction, so if you've got a bigger version of that, this is the most simplified answer. If you've got a bigger version, that's also fine. But obviously the point is that you need to have a surd in the numerator, and then a number, like a whole number, an integer in the denominator. Their example that they would also accept was 2,187 over that, but I don't know why you would have worked that out, because that seems... I'm assuming that's 3 to the power of 7, I don't know. I wouldn't have worked that out, because that's a non-calculator question, and I would rather not have to deal with big numbers, so that's why I did it this way. But as long as you know, obviously, if you get a fractional power, it means a root. But also, if you get a root, you can reverse it and write it as a fractional power, or a decimal power, in this case 0.5. You can do that, that's fine. It works both ways. Okay, question 19. This is a really nice question. So we've obviously got here, we just need to be able to recognize this format. That means completing the square. So given that x squared minus 6x plus 1 can be written as this for all values of x, find the value of a and b. So basically complete the square is what that is saying. Complete the square. So what we do, oh, please don't start banging again, is you half the middle term. Obviously keep the same symbol, half it, so that's 3. That's what goes in the brackets squared. On the outside, you're going to subtract this number squared. Oh, if it's negative or positive, it doesn't really matter, because obviously when you square it, it becomes positive. So you're subtracting that squared, and obviously then the 1 is still here. So all I need to do now is work out minus 3 squared is positive 9, but I'm subtracting it. So you see how I've got minus 9 plus 1, and that gives me, just be really careful with the negatives, minus 8. So they said, what is a and b? Now, just be aware though, do you see how, highlighter, they've already accounted for the negatives, haven't they? They've already said that. So in terms of a and b, my answer is 3 and 8, because they already put negatives. If they wrote it like this, then yeah, a and b, you would have to put the negative in yourself. So just be careful, what have they written? Have they already accounted for the negative? Or have they not? Because you could lose a mark if you put the wrong positive or negative, right? Okay, part II, hence write down the coordinates of the turning point of the same graph. So this is really easy. Looking at your completed the square version, obviously those numbers are the coordinates. This one is the x, but you have to change the symbol. Whatever the symbol is, you swap it. So in that case, x would be positive 3. This one is the y. You don't change the symbol, keep it the same. So that would be minus 8. So if you ever see a question that says turning point of a quadratic graph, it's always complete the square. So it's just knowing that as well. Okay, proportion, as I said as well, also comes up quite a lot in non-calculator for whatever reason. This one is what I'd call double proportion because we've got two relationships. Now, proportion questions, for the most part, I normally write them or split them into 3 steps. So my first step is here, my second step is this line, my third step is the question. So first step is to write out the formulas. In this case, there's 2, right? Because there's 2 equations, 2 relationships. So you just have to memorize the formulas. For direct proportion, it's normally y equals kx. Obviously, I'm going to change the letters. And for inverse, it's normally y equals k over x. In this case, you write the letters in the same order. So h is inversely proportional to p. So that would be h is equal to k over p. I've just swapped the letters, right? And then for the second one, it would be p is directly proportional, so k. Technically, we should probably use a different letter because they're not the same k, right? But I don't think they really would penalize you. Now, if it says anything other than just t, obviously you would copy that. So root was just the root of t, not just t. So step 2 is then to find the values of the constants k. Obviously, they will be different, so substitute in the matching pair that they give you. So they've given us h is 10 over p is 6. Make sure you obviously get the right numbers. Now, do you see how I could just solve that by timesing? And then I would rewrite the equation just so that when I come on to step 3, it's there. So h is equal to 60 over p. That's the relationship, actually. Now, over here, p is 6. Again, they gave us there. And then t is 144. So you see how that gives me 12k. I know, again, the k's aren't the same number, for they are different relationships. So divide that would actually give me a half. So that would be p is equal to a half root t. So that's step 2. Now step 3, you can actually look at what the question was. They said in this case, find a formula for h in terms of t. When that says h in terms of t, that means h is the subject and everything else here just has t's. Obviously in numbers, but t. We don't want p. So we need to link the 2 equations together. They both have p. Do you see how I could substitute in? Instead of p, I could write a half root t. So 60 over a half root t. Do you see how now I've just got h and t? Now, I have seen the answer because do you see how it doesn't say to simplify it? I know you wouldn't normally put a fraction within a fraction. It doesn't say to simplify, so they would accept this. You don't even have to rearrange it if you don't want to. They would accept that. But just in case you wanted to rearrange it to not have a fraction, the other options are they will accept you writing 120 over root t, which is not rationalized, so they will also accept if you rationalized it, which is 120 root t over t. Any of those 3 answers they will accept, or any equivalent of that. But they would accept this original, so you might as well not do any more work, to be honest. Okay, I think we've got 2 questions left. 21, functions. Functions, again, seems to come up quite a lot in non-calculator papers. So, the functions f and g are such that f of x is 3x minus 1 and g of x is x squared plus 4. First of all, find the inverse function of f, so that's quite straightforward. I would write y instead of f of x just to make it easier. Some people like to swap the x and the y now. Some people like to swap it at the end. It doesn't really matter, I swap it at the end. So I'm going to make x the subject, so I would obviously add 1, and then I would divide by 3. You can obviously do it in more than one step than that if you want. Obviously then rewrite it, I swap it at the end, so that's x plus 1 over 3. Really nice 2 marks. Oh, don't want to zoom. So, I don't know if you can still see that. The functions, they've given us an equation now, so this is like using equations. So they said, given that f of g of x is the same thing as equal to 2 of g of f of x, show that we get this equation. So basically you want to create this equation with your functions and then rearrange it to get what they've got. So we want to find the composite function, first of all, of f of g of x. You always substitute in backwards. So in that case, I'm substituting in g into f. So wherever there's an x, I'm going to replace it with the whole of g. So that would be that side. Now the other side is not just the composite function g of f of x, but it's also 2 of that. So 2 times, now this one again, backwards. So that would be f into g. So wherever there's an x, I'm going to put the whole of f, which is 3x minus 1. So I would have to square that plus 4. So that's my equation when I set it up. Now all I need to do is just rearrange it, expand it, simplify it, move it around until I get exactly what they gave us. So that would be 3x squared plus 12 minus 1, right? On that side. This side, I'm probably going to expand out the brackets here first. So that would be 9x squared. Remember, that's double brackets, not just 3 squared, not just 3x squared, not just minus 1 squared, it's double brackets. So that would be minus 6x plus 1. Be careful with your symbols there. And there is still that plus 4, isn't there? So that would give me 3x squared plus 11 on the left, and then obviously that would add up to make 5, but if I expand that, 18x squared minus 12x plus 10. Now, I want to get what they got. Do you see how they've got the x squared positive and all the terms on one side? So I'm actually going to move my left-hand side to the right. It doesn't matter if your zero's on the other side as theirs. What matters is that you get the same symbols. So if I take away 3x squared, that still gives me positive 15x squared. That's the most important thing. Obviously, we've still got the minus 12x. And then take away 11 would give you minus 1. So that's the same thing. I know it's like the other way around, but the symbols are all the same. So that would be the same thing. And that one's 5 marks. So it's just composite functions, basically, and then a bit of rearranging, a bit of expanding. Okay, last question. This one I actually have gone through in one of my actual videos, the hardest Edexcel questions on probability. So if you want to kind of have a look at that at another time as well, it will be on that video, probably in a more succinct explanation as well. But we'll go through it again anyway. So this is 5 marks. So there are only R red counters and G green counters in a bag. So they've given us letters. Yeah, I think function, but well, yeah, I think functions mostly is on non-calculus, but it will come up at some point, won't it? Definitely, I think. So because they've given us 2 letters, it's kind of making me think I need to use algebra. I probably would have done anyway, but it's giving you a hint, isn't it, in this case? It's giving me a hint, R and G for red and green. A counter is taken at random from the bag. The probability that the counter is green is 3/7. And then they put the counter back in, but they've also then added 2 more red and 3 more green counters to the bag, and then again they take a counter at random. The probability of getting green now is 6/13. We need to find the number of red and the number of green counters that were in the bag originally. This here, even though it's probability, the context, I would say, the actual working out is simultaneous equations. Because I've got 2 things that I don't know, R and G, I've got 2 letters I don't know, and they've given me enough information to create 2 equations. So that's simultaneous equations, isn't it? Under the context of probability. So let's set up an equation for the first bit. The probability of getting a green counter, how would I write that? Well, that would be the number of green counters, which is G, out of the total number of counters in the bag, which is just red and green, isn't it? So that would be R plus G. Do you see how that would be the probability of getting green originally? Now that, I know, equals the 3/7. So I've created 1 equation, but obviously because I've got 2 letters, I need 2 equations, which is now the second bit. So we need to take into account the fact that they've changed the number of counters. So the probability of getting green again, how many green counters are there now? Well, there was G originally. They've also added 3. So see how the numerator is now G plus 3. And also the denominator, the total number of counters has changed as well. We've got not only just the red counters originally, we've also got another 2 red counters. We've not only just got the G counters originally, we've also got another 3 green counters. That is what equals to 6/13. Again, this is kind of the hardest bit. I think setting up the equations originally is the hardest bit. From here, it's just solving equations, simultaneous equations. So I'm just going to kind of rearrange it. You might solve it differently to me, that's fine, as long as we get the same answer at the end. Shouldn't matter. So I don't really want fractions, I'm going to cross multiply. The other one I'll also simplify as well before I get that far. So that would be 7G is equal to 3R plus 3G if I were to expand that. And I would probably just collect the G's, might as well. So I'll take away 3G, so I get 4G equals 3R, so that's a bit more straightforward, isn't it, that one there? This one, obviously add the 3 and the 2 because those are like terms. You get R plus G plus 5. And then I would also then cross multiply. Okay. So 13 times G, 13G, 13 times 3, 39. 6 times R, 6R, 6 times G, 6G, 6 times 5, 30. So at least it's all in one line. Again, I'm going to collect the like terms. So for this one, we've also got numbers, haven't we? So I'm going to get the G's together. So I'll take away 6G, which is 7G. I would probably take away the 30 just to keep this as a whole number, I guess. Well, sorry, not a whole number, but to keep it as a positive number. That's what I'm trying to say. Also, because when I get that, if I compare my two equations now, they're both linear, aren't they? They're both linear equations, as in they're not squared or anything. So I can either use elimination method or substitution method. Now, what I was looking at was the fact that I've got 3R and a 6R. So I can make those the same, can't I? That's a bit easier than the 4G and the 7G. I think that's a bit easier. So what I did was I just doubled both sides of this first equation to make it 6R. So that'd be 8G, 6R. Now, you can either use elimination by, where am I getting 4G from? Back here. Oh, where's my pen? This bit, do you see how I subtracted? I just moved the 3G across. Yeah, exactly. 7G minus 3G. I just moved it across to collect the like terms, because I might as well get all my G's together. That's where I got it from. You can obviously write that out fully if you want, as in minus 3G on both sides, so it moved across. Okay, so I've made them the same. So now let me get my highlighter over here. There we go. Now you can either obviously same sign subtract, you could subtract them, or I just put them equal to each other. I guess that's technically substitution, isn't it? I just put them equal. 6R is equal to 6R, therefore 8G is equal to 7G plus 9. However you want to do it, substitution, elimination, doesn't matter. You'll get an equation with just one of the letters. Obviously now I'm going to take away the 7G to move it across and keep the G positive. So I'm going to take away 7G, which gives me just 1G, is 9. Now, because the G and the R, if we come back, was the original numbers, wasn't it? It was the original amounts. They said work out or find the number of red counters and green counters originally. So yeah, that is 9 for green, isn't it? Now, that's the hardest bit. Now the easiest bit is then to just sub that back in. Choose any of your original equations. I would probably choose just the simplest one. So sub G is 9 into the original. Let's call that equation 1. That one can be called equation 2. You don't have to write that in your working out. I'm just doing it so you can see what I've done. So we know what we know what G is. It's 9. So 4 times 9 would be the same as 3R. Now you just solve that for the red. So 36 equals 3R. Divide by 3. 12. There you go. So do you see how actually the probability was only just the context enough to give you the first two equations? Once you got the first two equations from there, it was then just solving simultaneous equations. So sometimes, quite a lot of the time, they might overlap two topics or put two topics into a question. It might originally appear to be fully probability, but actually it was algebra as well. That's fine. This will upload itself once we finish the live. So if you want, you can kind of go, or you can go backwards. You can scroll back. You can, what do you call it? Rewind. You can go backwards and watch it again. It will upload itself after this anyway. So you can see the middle bit. But yeah, that was 5 marks. That was the last bit of the paper. Okay, so I think that was a fairly nice paper, apart from like a couple of those that were a little bit harder about the power one, the power 6 one. That one wasn't so great, but the rest, there was only 1 mark. The rest of it wasn't too bad. So 80 marks. That was the June 2019 paper 1. On Wednesday was our next one. Wednesday is our next one. We will go through November 2019. We're just going backwards, basically. I'm also going to put together a probability, sorry, not a probability, like a predicted paper. I'm going to put one together with based on what I've seen is repeated. So I'm going to try and create that myself. So I don't know if I would do a video on that anyway, but I don't know if you want me to do a live on that, a predicted paper that I'm going to make up. Instead of doing one of the past papers at some point. Can I go through the start of this? Yeah, hang on, let me go back to the because that's the main thing, isn't it? You need to get the equations in the first place, otherwise it's kind of hard to do. The G plus, yeah, the second one. So that's this information here, isn't it? This information there. So the probability of getting green again is, oh, we almost made it through the paper before they started banging again. The probability of getting green after they've changed the number of counters is now, so how many green are there? The original number was G, isn't it? That's how many, that represents a number, doesn't it? When now we know it's 9. The original number of green counters plus the 3 additional ones. So that's how many green counters are now in the bag, and then you have to do it out of how many counters in total are in the bag. So that's all of the red and all of the green. Do you see how the red also changed? There was 2 more red. Right, so I did the red originally plus the 2 extra red, and then the green originally plus the 3 extra green. Obviously that equals 6/13. Okay, I know someone had just another random question that was not on this paper, but I'm going to go through that now, so that's just for Gina. We'll go through that now. But otherwise, as I said, all of the resources are in the description of this live if you want to have a look. Anything that I've created a video for, I've linked down below. If it's not there, it's because I don't have my own video for it just yet. I've also linked down below kind of other ones like hardest Edexcel past paper questions on different topics and the most repeated ones. Those are quite good because they come up a lot. Different playlists, all of the resources are down below. So have a look at that as well. Okay, I'm just going to have a look at Gina's question now. 6 balls with a... Was there a diagram with this question, Gina? Do you know? Just because I need to know how... Did they fit inside, like all flat? Was it like stacked on top of each other? That I think we... Does it tell you? So the diameter of 5 fit into a cuboid, work out the volume of the cube. Was this from a past paper? Because I might be able to find... I don't know if you know which past paper question it is. I might be able to just find it and copy it on. Or if it's just a random question. Yeah, I'm thinking to make a predicted paper. I feel like, well, that might be quite difficult, but based on the topics that I think are most common, I'm going to just see if I can put together my own paper. And do that. So I'm going to make a video recording, like editing, and that will be edited and everything, but also I don't know if you want me to do that as a live, like my own predicted paper. Again, it's obviously it's not necessarily a prediction, it's more just what I think is most commonly going to come up. It's not a guarantee, so don't rely on that. But I'm thinking to maybe do that in a live. Oh, okay. So you just had 6. Was it like all 6 in a row? Was it like 2 by 3? Like 2 and 2 and then 2 and 2 and then, do you see what I mean, like that? Was it like that, or was it like just 6 in a row? How was it? So, you could create like a cuboid, like that, for example. Was it like that, or was it... this is a horrible drawing, but you get the point. Was it like that? 3 in a row. So like this one here, more or less. Yeah. Okay, let's see. Let me get rid of this. Obviously, just a lovely drawing there. Okay, so we know that the diameter... you said was 5, so then that's also 5. Obviously, I've not drawn them stuck together, but they are stuck, aren't they? They are stuck together. 6 balls of diameter fit inside a cube. I'm assuming, yeah, they like overlap, don't they, effectively? So then we know that this width here is 10. We know that the height, because the diameter also works vertically, isn't it, is 5. And then we know backwards would be 3 lots of 5. So that would be 15. So then all you need to do, because that's the only three measurements you need, the three sides you need to find the volume of a cuboid. The volume of a cuboid would be just all of those times together. So what's that? 50 times 15. 750, I think. Let me double check. 750, yeah. That should be the answer. 750. In 3D trig, what does it mean by find that? Oh yeah, that comes up a lot, especially in Edexcel. That particular question. I can find it one quickly if you want, because yeah, it's quite consistent, that question. I think I might have put that in my most common 3D, my most repeated trigonometry questions video as well, which is linked down below. But I'll show you quickly anyway. Well, let me just grab a question so I don't draw it. We'll give you an actual question. 3D trig. It's always an angle between a plane or a base or something, isn't it? It's quite common here. And then let me copy and paste it, please. Let me print screen it. Don't let me paste it. Okay, I might have to draw it. This is not going to go well. Oh, we don't want it pink. Let me upload the paper actually. June 2018 paper 2, there's one on that one. 2. Question 18. Just give me a second to upload that one. This one here. Here, for example. So you've got a cuboid. They've said, oh, they haven't labeled it, so let's label it. A to B, where's that at the back? Well, I'm just going to label the front because that's easier to label, isn't it? That's the same, isn't it? 7.3. C to H, the height 8.1. And then they've said angle BCA, where's that BC to A? So I would draw that, right? I'll draw that line. Whatever they suggest, draw that. And why is it pink? I want it to be pink. I would draw that because I think that's actually helpful in this question. So you draw that, then that's 48, like on the base, literally on the base, isn't it? So then they've said find the size of the angle between AH, so draw that, and then the plane, ABCD. Now because I drew the AC, the angle is this. Well, Aaron, I have a video, well, I have multiple videos. It's on the hardest questions. It might be grade 8, grade 9 ones, but it's like, they're different. They're not all the questions. It's like, I've got one on trig, I've got one on vectors, I've got one on like indices. So I have got a few of those. They're linked in the description if you have a look. They're called the hardest questions. So I guess that would correlate with grade 9, wouldn't it? So just scroll down through when it says watch next. It says hardest Edexcel past paper questions. I've gone through it in terms of, I think I've got like 6 different, what am I trying to say, different topics. I know it's not all of the topics, like it doesn't encompass all of the hardest questions, but that might be a good place to start. So when you've got the angle between a line, now normally the line is like the diagonal one through the shape, isn't it? So draw that line, and if it says the plane or the base, draw a diagonal line from obviously where your corner touches, so in this case it would be A, diagonally across. So in this case I had to draw it anyway because they said the angle BCA, so I had to draw it anyway. But that's what I would draw. Now it's normally always, like your triangles normally always stood upright, or like, it's either vertical or horizontal, if you get what I'm saying. It won't be, let me get rid of this quickly. Let's say you didn't have that line there. Like it won't be this. Do you see how that's like an awkward diagonal? Like that's, it won't be that. Okay, so if you've got the plane, Go backwards. Then draw a diagonal line through the plane. Okay, to match up with whatever corner you've obviously got. And then you'd go from there. If I found one that was kind of harder, but I don't know if I have it here. Oh, is it this one? I think it's this one. Let me see if there's a June 2022 one as well. Let me just upload that just so you can visualize a different shape. June 2022 paper 3. Where's that here? Question 18. Oh, I'm glad it's helpful. Yeah, check out the videos I've got. Obviously, I've done lives as well on previous past papers as well. So have a look at those. They should all be uploaded. The ones that you might not have seen, because we're working backwards in chronological order. Question 18. Where is it? I think it's this one. There. Do you see how like the line ST is kind of awkwardly, not in the middle, but it's like halfway, well, that's the same as the middle, isn't it? It's going through one of the lines, and not to a corner. So this one, you've got find the size of the angle between the line ST, which they've drawn, and the base. So in that case, I would probably draw my diagonal line from T to D, because you see how like the corner S is directly above the corner D, so that would create my upright triangle. Like there's no diagonal triangle there, is there? In the case of like, it's not slanted, it's an upright triangle, so that would be the angle. So I don't know if hopefully that answers your question on the base. Obviously then you just carry on and do it as you normally would. I think once you've identified which angle it is, it's kind of not too difficult. But yeah, you can see they've asked that multiple times. Which one is angle of elevation and depression? I mean, isn't it just elevation is up and depression is down? I don't think that comes up very often in Edexcel. Maybe the GCSE more so, or maybe another exam board. Like as in, if that's your straight line, isn't the elevation that one and then the depression that just up and down? Isn't it just like that? I'm pretty sure. I think you just literally take it as elevation means up and depression means down. I'm pretty sure it's like kind of as straightforward as that. Yeah, I haven't seen, I mean, I think maybe the GCSE Edexcel one, I've seen it being asked. I don't know if you do GCSE or just GCSE. This one is elevate. Like just think about the definition of elevation. Elevation is going up, isn't it? And then depression is like D, and normally things that start with DE are going down or decreasing or something like that, isn't it? That's normally. You do normal GCSE. Huh. Let me see if I had. Maybe there was because I would assume this would just be a normal like basic trig SOHCAHTOA situation. I've not really seen them ask that though. They normally just give you a literal triangle. If not, I can have a look on maybe Maths Genie or something. Yeah, no. No, nothing there. Let me check Maths Genie for if they have that topic. Elevation. No, they don't even have it on Maths Genie. I'll try and copy a picture. I think this picture probably explains it. Oh no, I don't want to click on it. Let me see if it'll let me paste it. Copy image. It gets to a point where it doesn't let me paste anymore for some reason. Okay, let me just drag this Google. Hopefully you can see this. Oh, it's put it there, look. There we go. This is the one that I was looking for. Do you see how like whatever the line is, the horizontal line, its elevation is above if you're looking up. Imagine that, and then elevation and depression is if you're looking down. That's all it is. If you have a question, yeah, you can send it. Hang on, are you sending it via my email? Let me open my email. Yeah, you can send it through on my email and I'll copy it across. But effectively, it's just whether you're going, like, wherever the horizontal line is, if you're going up, then it's elevation. If you're going down, it's depression. I don't know if that comes up that much, though. So it's, and then beyond that, you would just create, like, for example, here, if you wanted to know that angle, you could create, like, a triangle, couldn't you? Like, if I drew a line here, see how that would be right angle? And then let's say they gave you, you know, information about the sides, then you'd be able to work it out. Yeah, let me know if you send that to me. Okay, hang on, let me just refresh it. I've got your other two. But I'm just waiting for it to come through. It's taking its time. Not come through yet. Oh, there we go. Hang on. Yeah. Which question is it? Hang on, let me scroll through and have a look. Oh, question 14. With the balloons. Yeah. If it'll let me copy it, hopefully. Oh, I might need to download it. This one here. Okay, there we go. Right. The diagram shows two hot air balloons. A is a point on the base of one of the balloons and B is a point on the base of the other balloon at K. The distance between A and B is 500 meters. The angle of depression of... Oh, okay, you're trying to translate what that means. Yeah. Of B from... I'm assuming it means this, just from the diagram. Like, I'm assuming that it means that is 23. Calculate the vertical height of A above B. I'm assuming that means, like, let's say if we were to carry this on. So you drew, like, I'm assuming you drew that line there. And then, so that would be like, let's say that was a straight line. And then if I drew this straight down, that's a right angle. We know the length of this is 500. We want to know, I guess, this side. So that's the opposite. That's the hypotenuse. So I would use sine. SOHCAHTOA, we want to know the opposite. So sine of 23, that's not 23, that's 32. Get the numbers right around. Times 500, which I type into my calculator. I get 195 point, I don't know what, oh, they want it to one decimal place, 0.4. When they say the vertical height of A above B, I'm assuming it's just that side. I don't know if they mean anything else beyond that. But this side here, that side of the triangle, I wouldn't do sine rule, because sine rule is for when you've got just random triangles. When I say random, I mean like a scaling triangle. In this case, because I've created a right angle triangle, I just use normal sine. So like SOHCAHTOA, not necessarily sine rule. But I don't know if that's what you mean. Yeah, I don't know, because the depression, angle of depression is from like a horizontal line. So that's the line I think you drew there. Imagine that's literally horizontal, and then down. So that's why I created a right angle triangle. Yeah, I think with angles of elevation and depression, it is just normal trig. I'm pretty sure it's just normal trig, because based on the elevation and the depression, you always have a horizontal line. So if it was elevation, it'd be like that, and you'd create still the same right angle triangle from that. You know? Like if I come back to, where was it? This one. Do you see how either way you can create, because it's always based on this horizontal line, it either goes above to be elevation or it goes below, and that would always create that here, a right angle triangle. So I think for that topic it's just normal sin cos tan. I don't think it's even, I know it's kind of towards the end of the paper, so you might be thinking, oh, it's harder than that, but I don't think it is. I don't think it's more complicated than that. So yeah, it's just relating it, like figuring out what they mean by that. Depression is down and elevation is, like, let's say if they had one here, then the elevation would be that angle, wouldn't it, from the horizontal line, but above. In this case, you could see that it was going downwards, wasn't it? So that's what I got. I don't know if you have the answers, if that's the correct answer, but that's what I would have done. And I'm assuming it was just this height that they wanted, like this, as in kind of like this distance, which is the same. That's still 23. That hypotenuse is still 500. You could then work out that would still be the 195. You can look at it either way, because I guess these are technically parallel lines, hence why both of those are 23. So however you want to draw your triangle, but I'm assuming that's what they mean by the height of it. I don't know the vertical height of A above B. I'm assuming that's what they mean by that. I'm assuming they don't mean this bit here. Although I guess that's the same, isn't it? That would be the same height. So, yeah. Yeah, I mean, in the Q&As, I've done a lot of vectors questions. Obviously, that's the main question. So there is a Q&A live that I did last week or the week before. That's uploaded to my channel. That's called Vectors Proof Q&A. So you can look at. I can link that as well. I'm just saying, just because we've gone through it a few times. And I've also got my own videos on it as well. I've created my own videos on vectors, so it would probably, like, any of those videos I think would probably answer your question anyway. So, hang on, vectors, where is it? I'm going to send some links. That's the parallel proof. Obviously, there's also the harder one, which I would call like the ratio one. I think that's also harder. So there's that. vectors, oh, did I spell it right? Vectors, ratio, and scale. That's this one. And then I've actually gone through some past paper questions on it, which that might cover it as well. This is the hardest. Edexcel. Vectors. That's the hardest one. I've also got most common ones, but that would include like ones you probably don't mean. So like column vectors, obviously you know how to do that. The hardest, that's probably this one. If you have a look at this video, it's on the hardest vectors questions generally. You can obviously skip through and find the ones that relate to you. That's probably the best one for you. Otherwise, I did do a live on it, and that was the kind of most commonly asked question. So I can find, where's the link to that live? Live, it was probably, oh, it was like a week or 2 weeks ago. Obviously this is not edited though, right? So you might find that the other ones are actual videos that I've edited. So probably from any of those, if you ever look through those videos, I think it would answer your question on vectors proof. If not, if there's a specific question you find that you want to look at, you can bring that to the next Q&A. We can have a look at a specific question, but we have obviously gone through these already. So just for the people who come repetitively, you've got those there to have a look at in your own time as well. But yeah, okay. Otherwise, guys, I'm going to finish the live there. Our next one is on Wednesday. We'll be going to another paper. I'm thinking whether to do a Q&A on Wednesday as well, so we'll see. But yeah, keep an eye on my channel and it will obviously notify you as to when my next live is. But yeah, otherwise, thanks for coming, guys. Thanks for interacting. Hopefully it was helpful, and I will see you on Wednesday.